Let knowledge flow like a river without any hindrance. Don't make it like a stagnant pool. Design a pile cap by few clicks. Part 5 6 Piles Cap. Hello everybody. I'm PS Chatterjee with you. Today I am going to explain you how we can prepare Excel Performer for the design of 6 pile cap. I hope you are going to enjoy this video. Before start of the lecture, please like, share and subscribe my channel. Your views, likes, share, comments and subscription are the inspiration and remuneration of my hard work. Types of 6 pile cap. Type 9 in Z direction, type 10 in X direction. Dimension of pile cap. Pile cap dimension, length LA, width LB. Spacing of pile S. Column dimension, CX in X direction, CZ in Z direction. Dimension of punching area, BX in X direction is equal to 2D punch plus CX. BZ in Z direction is equal to 2 into D punch plus CZ. Overall depth D. Punching depth D punch. Lever arm for type 9 in X direction Jx is equal to 0.5 S. In Z direction Zz is equal to S. Lever arm for type 10 in X direction Jx is equal to X and Jz is equal to 0.5 S. Loads on pile cap for type 9. Total self weight of pile cap is equal to capital SW. Self weight on each pile, small sw, is equal to capital SW divided by 6. Say load on P1, P3 and P4, P6 is equal to R1. R1 max is equal to SW plus Fy by 6 plus absolute Mx by Zz by 2 plus absolute Mz divided by Jx divided by 3. R1 minimum is equal to S smallest w plus Fy by 6 minus absolute Mx by Zz divided by 2 plus absolute Mz divided by Jx by 3. Say load on P2 and P5 is equal to R2. R2 max is equal to SW smallest w plus Fy by 6 plus absolute Mz by Zz divided by 3. R2 minimum smallest w minus Fy by 6 plus absolute Mz divided by Zz divided by 3. Load on pile cap for type 10. Say load on P1, P3, P4, P6 is equal to R1. R1 max is equal to SW plus Fy by 6 plus absolute Mx divided by Zz divided by 3 plus absolute Mz divided by Jx by 2. R1 minimum is equal to smallest w plus Fy by 6 minus absolute Mx divided by Zz by 3 plus absolute Mz divided by Jx by 2. Say load on P2 and P5 R2. R2 max is equal to SW plus Fy by 6 plus absolute Mx by Zz by 3. R2 minimum is equal to SW minus Fy by 6 plus absolute Mx by Zz divided by 3. And as usual, this is our shear force and bending moment diagram. Shear force and bending moment for type 9. Maximum shear force V is equal to 3 into R1 max. Maximum bending moment is equal to 0.5 into S into 3 into R1 max. Maximum SF in Z direction 2 into R2 max. Maximum BM MZ is equal to S into 2 into R2 max. Now I'm switching over to the Excel spreadsheet for numerical calculation. Welcome to my Excel spreadsheet for design and analysis of pilecap by few clicks, part 5. That is 6 piles cap. These piles cap are two types, in X direction and Z direction, because it is rectangular array. I have increased the column load here. 5 pile cap is not sufficient. So I'm changing here 6 pile cap in XZ direction. This is our column load. Now I am considering the increment. As usual, diameter of pile 500, center to center distance of pile 1500. Now I'm changing here friction pile in clay or sand to hard clay. Minimum spacing 1250. 1250. Capacity 500. Now I am considering increment in pile capacity. Allowable increment 50%. 50%. Load reduction we can consider say 14%. Maximum load on pile is less than maximum capacity of the pile. So it is okay. Now I am considering the efficiency. Once again, maximum load is more than the maximum capacity of pile. So we can increase this pile capacity up to 25%, say 20%, 600. It's okay. And we can change the grade of steel to 500. Look here, punching shear stress is higher than design punching shear stress. So I'm changing punching depth 600, not okay. 650, not okay. 700, not okay. 750, not okay. 800, okay. One way design shear stress 0.61 in X direction and Z direction 0.38 Newton per millimeter square. Calculated shear stress 0.9 and 0.9 Newton per millimeter square. Now I'm changing here bar dia in Z direction, spacing 80, 75, 75, overall depth 1 meter, not okay. 1200, not okay. Fifty, okay. 65, not okay. 60, not okay. 50, okay. And this is 50. Look here once again our self weight increased. So we have to increase the pile capacity. we have considered 20%, but now I'm considering 25%. 625. Our design is okay in Z direction. Now I'm changing from Z direction to X direction. That is type 10, 6 pile cap. The maximum load on pile in load case 101 is 481. Due to the nature of the moment, this load increased. What can we do? We can reduce this value 1000 and design is okay. This is our total calculation sheet, and this is load case, loads, number of minimum pile required, check for minimum reaction, sliding check, etc. This is all about my design of pilecap by few clicks part 5. I hope you enjoyed it. Part 6, that is 7 pilecap, will be released very soon. Please don't forget to subscribe my channel and also evaluate my performance with your valuable comments. Excel sheet will be distributed after the release of part 8. Thank you.